Keep the heading dimensional analysis. Fine. Now what is the use of dimensional analysis? What is the role of dimensional analysis? What is the use of dimensional analysis? An idea on them? Do you have any idea about dimensional analysis? Only correctness of the equation. Fine. See, sometimes in mathematical calculations or else in chemistry, even in chemistry also use the dimensional analysis concept. Sometimes in mathematical calculations in physics, we have to depend on the similar quantities again and again. Okay, no, we have to depend on the similar quantities again and again. In such cases, instead of using the equation, physical equation again and again, we can use the dimensional formula. Okay, for suppose, do you know the formula for force between two masses or Newton's law of gravity? What is its value? Is G into m1 m2 divided by r square. I am going with a simple equation. Actually, it is a simple equation. We can repeatedly, we can write, no problem. But sometimes in physics, you will get the complicated equations, very big equations you will get. In such cases, every time representing that equation is little bit difficult. In such cases, instead of taking that big equation, you can represent with the dimensional formula like this, mLt power minus 2. So mLt power minus 2 means it is nothing but force. Are you clear? mLt power minus 2 means nothing but what? Force. In some cases, we will get some values like R into C, where R is resistance, C is capacitance. Are you clear? Where R is resistance, C is what? Capacitance. Here we will study this as a time constant, if you remember. Are you clear? So in order to explain this RC concept easily, we can represent with the time constant T, which is represented with the dimensional formula T. Okay, so please remember, sometimes in order to explain the complex equations, we will use the dimensional analysis concept, because those kind of complex equations always repetition is not possible. Are you clear? Repeating those kind of equations, complex equations, is always not possible. So that's why we'll use the dimensional formulas. Or else we have an unknown parameter, let us say RC. RC is an unknown parameter, let us say it is a time constant. Are you clear? So resistance, if you take resistance unit is what? Ohm. Capacitance have one more unit, that is called as farad. Are you clear? So always instead of writing capacitance and farad ohms, resistance unit as ohm and farad unit as capacitance unit as farad, and always in order to represent the dimensional formula, we can simply represent with one equation, that is time. Are you clear? So this is the advantage of dimensional analysis. Are you clear? Now how to explain the physical quantity with the help of a dimensional analysis means, if you take any physical quantity, I will take any physical quantity Q. Clear? I will take any physical quantity Q. Any physical quantity can be expressed as product of. Are you clear? Product of. Product means multiplication. Okay, it can be expressed as product of, are you clear, powers of base quantities. mLt, that is mass, length, time. These are taken as which quantities? Base quantities. Are you clear? These are taken as what? Base quantities. So please remember. So any physical quantity can be expressed as the product of base quantities. Then tell me, according to the SI system of unit, how many fundamental quantities are there? 7. What are those? Length. Are you clear? Next one, mass. Next one, time. Are you clear? Next one, electric current. Okay, then next one, thermodynamic temperature. Okay, then next one, amount of substance. Clear? Amount of substance. And finally we have one more, that is luminous intensity. Clear? Next one is luminous intensity. Now try to understand, length can be taken in any type of units. Either length can be measured in centimeter or millimeter or kilometer, and some other units of length. Angstrom, are you clear? One Planck length, one Fermi, as well as if you take long distances, one astronomical unit. Are you clear? One parsec, one parallatic second, and one light year. All these are the units of length. Are you clear? Okay, based on our convenience, we can explain with either millimeter or kilometer or centimeter or parsec, or else angstroms, or else Fermi, or astronomical unit, or parallatic second, or light year. But any type of unit you take, the dimensions of length can be taken as or represented with L. So wherever you see in the length or distances, are you clear, or any type of units like this, you can represent with the simple dimensional formula L. And in the same way, mass is represented with the dimensional formula M. So mass can be measured either in kilograms or grams or any other units. Are you clear? Doesn't matter. But if you take the dimensions of mass, what is the dimensions of mass? M. In the same way, what is the dimensions of time? T. Dimensions of electric current? I. Or sometimes it is given as A also. Are you clear? Dimensions of current is taken as I or A. Then dimensions of temperature is represented with K, where K is called as Kelvin. Are you clear? Always the dimensional formula is represented with the square brackets. Or even you can represent with the theta also. Temperature even represented with what? Theta also. Then amount of substance we have to represent with MOL, mole. Are you clear? And luminous intensity is represented with what? Candela, CD. Now these are called as base quantities. Are you clear? Now listen, any physical quantity can be expressed as what? Product of powers of base quantities. That is called as what? Physical quantity or dimensions of a physical quantity. Just note down this point, just one point. So when a derived formula, are you clear, is expressed in terms of what? Fundamental quantity, which is written as the product of different powers of fundamental quantities. Or simply we can write a physical quantity can be expressed as. Okay, a physical quantity can be expressed as. Are you clear? A physical quantity can be expressed as a product of different powers of fundamental quantities. So here Q is called as a physical quantity. So what are the fundamental quantities, or this is also called as base quantities? Yeah, total how many fundamental quantities are there according to SI system of unit? 7. What are those? Length, mass, time, electric current, temperature, amount of substance and luminous intensity. So those dimensional formulas also are given, you can go through it. Is it done? Shall I move to the next point? So will you write these examples or not required? I guess it's not that much difficult to remember. Okay, you understood this, right? So length mostly in mechanics. So first year we are dealing with only mechanics. In mechanics only we'll deal with these three. In mechanics mostly we'll deal with the three only, M, L, T. Are you clear? So coming to the second year, okay, in coming to the second year, we have the other quantities. In thermodynamics we'll use this. Okay, in thermodynamics we'll use the fourth physical quantity. Okay, so that is temperature, that is temperature. Shall we move? So the next concept is dimensional formula and dimensional equation. Dimensional formula and dimensional equation. So the next concept is dimensional formula and dimensional equation. Now what is dimensional formula and what is meant by dimensional equation? Means for suppose I told just now any physical quantity is expressed as what? Product of powers of fundamental quantities or different powers of fundamental quantities. Product of different powers of fundamental quantities. Am I right? Then how much power we have to write, which physical quantities we have to use, that will be expressed with the help of whom? Dimensional formula. For suppose force తీసుకోండి. Force లో మనకు ఉండే dimensional formulas ఏమేంటి అంటే I guess everyone completed first year here. So no problem with that. Force లో మన dimensional formula ఏంటంటే ml power t power minus 2. అంటే m power 1, l power 1, t power minus 2. Now which base quantities we used? Mass, length, time. And what are their powers? 1, 1, 2. Are you clear? Now please remember, in order to explain a base quantity or in order to explain a physical quantity, which base quantities we used and what are the powers we used? That is called as dimensional formula. if you equate, that is called as what? Dimensional equation. If you equate, that is called as equation. If you just represent, that is called as formula. Are you clear? Just write down this short statement. Okay, just write down short statement. So the expression shows how and which of the base quantities represents. Okay, represents the dimensional formula. Okay, so that is called as what? Dimensional formula. And an equation is obtained by equating physical quantity with its dimensional formula. That is called as what? Equation. Now that is called as what? Equation. So equation means represent with the dimensional formula, with the physical quantity. Now example, if I take force, how to represent the force? F is equal to m power 1, L power 1, T power minus 2. So which base quantities we used? Mass, length, time. And what are their powers? 1, 1, minus 2. That's it. Is it done, everyone? Completed? Shall I go for the next point? Must see. Just now I told you where we have to use this dimensional formulas and all. Just now I told you, like, whenever we have the complex type of equations, instead of representing that complex equations, we can represent with what? Dimensional formula. Clear? So that is what one thing I explained here. For suppose in engineering designs and all, it simplifies the equations. It simplifies the equations, mathematical equations. Are you clear? In engineering and all, in physics and all, it will simplifies the mathematical equations, so that we can easily understand that mathematical equations, and we can get use of the these dimensional formulas to get the computational this mathematical equations. And similarly in physics and mechanics also, we can able to identify or compare the dimensional formulas with the physical equations. So that is nothing but checking the equations for dimensional correctness. And in chemistry and thermodynamics, we can use the concept of, for rate of reaction, all these things, we'll use this kind of, dimensional formula concept. Clear? Fine. We'll go for the next point. This is not that much having significance. Then you just write down dimensional formula for different physical quantities. Okay, dimensional formula for different physical quantities. Okay, dimensional formulas for different physical quantities. Okay, dimensional formulas for different physical quantities. Dimensional formulas for different physical quantities. Now see, in that first we can make that some columns, like first you write down serial number, and here physical quantity. I'll write the physical quantity here. Yeah, write down dimensional formula and last unit. Okay, dimensional formula and at last unit. Yeah, first we are going to discuss about the length. Length dimensional formula. What is the dimensional formula for length? Means L. So length can be measured in either millimeter or kilometer or any type of meter, any type of units. But in SI system of unit, we can represent the length with what? Meter. So I will represent this in SI system of units. So I will represent this in SI system of unit. And similarly, mass is represented with, mass is represented with what? Mass is represented with M. And unit is kg. And time is represented with T. And SI unit is what? Second. Then from now onwards, we will discuss different dimensional formula. Area. Area is represented with length into length. Are you clear? For suppose take anything. If I take a area of a triangle, half into base into height, right? Base also measured in millimeter or centimeter or kilometer, that is nothing but the dimensions of length. Even height is also measured in millimeter or kilometer or any dimensions of length only. So length into length, are you clear? Or else take area of circle. What is area of circle? Pi r square, means you can write pi into r. So r is measured in, r is nothing but radius if you remember. So r is measured in centimeter or millimeter or meters or anything else, which is again the dimensions of length. This are also measured in millimeter or meter or centimeter, which is also again dimensions of length. So which means that L into L, L square. So therefore area dimensional formula is what? My L square. Clear? Area dimensional formula is what? L square. And what is the unit of area? Means meter square, or you can write square meter also. Then volume dimensional formula L cube. Then we can write even it as meter cube. Then density. But tell you what the formula for density. Density is equal to mass by volume, right? Now the dimensional formula for mass is what? M. But the dimensional formula for mass is what? M. So density dimensional formula I will write M by. Tell me volume dimensional formula is L cube, right? So M by L cube, or you can write ML power minus 3. Now if I take units, mass unit is what? Kg, and volume unit is what? Meter cube. Kg per meter cube is the answer. I mean unit. Okay. Then I'll give you some dimensional formulas you can write down. Next, velocity. Velocity. So what is the dimensional formula for velocity? Or velocity formula is what? Displacement by time. So displacement is measured in again in meters or centimeter or kilometer, which is again the dimension of length. Therefore velocity can be taken as L by T, or T will goes to numerator L T power of minus 1. And tell me what is the unit of this velocity? Meter per second. Then next, acceleration. Yeah, acceleration. Acceleration is equal to velocity by time. If you want to copy this, copy this. If not, you have the study package, right? In the study package, one chart is there. Open that chart and see. You can go through that chart or else. Okay, instead of writing, you can open that chart and you can go through it. I'll explain few dimensional formulas just for our understanding. Chart is there. So you can go through that chart. If you want to write, you can write. If not, you just go through that chart what we provided in that study package. Undamadi? అవి చూసి ఒకసారి వెరిఫై చేయండి చాలు. ఓకేనా? ఇఫ్ యూ వాంట్ టు రైట్ ఫర్ ప్రాక్టీస్ మీన్స్ యూ కెన్ రైట్. ఓకే ఫైన్. Velocity is nothing but displacement by time, that is L T power of minus 1. Unit is what? Meter per second. Then what about acceleration? Velocity by time kada. Velocity means what? L T power of minus 1 by time is what? T. Then if T goes to numerator, T power minus 1. Already minus 1 is there. If this T goes to numerator, one more minus 1. Minus 1 minus 1 minus 2. So what will be the dimensional formula? Means L T power of minus 2. And what will be the units? Meter per second square. Okay, you know this, right? If this time goes to numerator, it is T power plus 1. If it goes to numerator, T power of minus 1, minus 1, minus 1, minus 2. Then next one, momentum. Momentum, you see, momentum. Momentum formula is mass into velocity. Is there? Yeah, once verify that momentum is there. Momentum formula is what? Mass into velocity. If you want to write, you can write, no problem if you copy from that study package also. But you know, dimensional formulas are very important. Okay, for NEET level 2 to 3 questions you can expect. Okay, fine. So mass for dimensional formula is what? What is the dimensional formula for mass? ఏంటమ్మా dimensional formula for mass? M. Velocity dimensional formula ఎంత? L T power of minus 1. So M into L T power of minus 1. Then total dimensional formula is ML T power of minus 2. Are you clear? Sorry, minus 1. So then what will be the unit? Tell me. For mass unit is kg, for velocity unit is meter per second. Then next, force. Force is taken as mass into acceleration. Then what is the dimensional formula for mass? M. Dimensional formula for mass is M into dimensional formula for acceleration. Just now we calculated LT power of minus 2. So the total dimensional formula is MLT power of minus 2. Then what is the unit? Mass unit is kg. Are you clear? And this is what? Newton per second square, or this is also called as Newton. Are you clear? What we call this as Newton. Are you clear? Then shall we go for the next one? Yeah. So the next one is work done. The next one is work done. Are you clear? The next one is work done. Work done, W is equal to force multiplied by displacement. Work done, W is equal to how much? Force multiplied by displacement. Then tell me for force, what is the dimensional formula? Force dimensional formula here just now we represented. What is that? M L T power of minus 2 into L. So the total dimensional formula is ml square T power minus 2. Then what should be the unit? Means Newton meter, correct? Newton meter only, right? So for force unit is what? Newton. And for displacement unit is what? Meter, or this is also called as joules, where joule is the SI system of unit. Are you clear? Joule is the SI system of unit. Are you verifying that? You are verifying the chart. Yeah. Or if you want to copy, you can copy it. Is it done? Shall I move to the next one? Next, power. My next one is power. So power formula is what? Work done by time. Are you clear? Then what is the dimensional formula for work done? M L square T power minus 2. Just now we calculated, right? ML square T power minus 2. By time is what? Time is T. So therefore the total dimensional formula is ML square. Ikkada T power minus 2 undi. If this T will goes to numerator, again T power minus 1. Minus 2 minus 1, that is how much? Minus 3. Are you clear? Then unit of power will be joule. Work done unit is joule. By time unit is what? Second. Joule per second, or this is also called as watt. Clear? Joule per second, or that is also called as what? Watt. So just note it down. Or if you are following that, okay, follow that. Okay, fine. Shall I give the next things? Now please remember, energy and work done will have same dimensional formula. Energy and work done will have what? Same dimensional formula. Remember. Yeah. Then I'll go for the next things. Frequency. Now frequency. Frequency formula is 1 by time. Undadi? Undamma frequency. Is there a frequency 1 by time? Is there a? It chudamma it. Ikkada chudu. Is there a? Frequency is what? 1 by time. Is there, right? So frequency is equal to 1 by time. Then frequency 1 by time ante 1 by t, that is equal to t power of minus 1. What is the frequency dimensional formula? T power of minus 1. Then what is the unit? T power of minus 1 means second inverse, or this is also called as hertz. Are you clear? Next, I am going to discuss some few things. Okay na? ఇవి రాయండి, లేదా మీకు అక్కడ బుక్లో ఉంటే కొంచెం దాన్ని అండర్లైన్ చేసుకోవడం లేదా బాక్స్లో పెట్టడం ఏదో చేయండి. ఎందుకంటే బేస్డ్ ఆన్ దట్ ఐఎమ్ గోయింగ్ టు గివ్ యూ సమ్ డ్రాబ్యాక్స్ ఆర్ లిమిటేషన్స్. ఓకేనా? యా. ఇన్ దట్ యాంగులర్ మొమెంటమ్. So angular momentum is represented with L. Are you clear? That angular momentum can be taken as, okay, linear momentum multiplied by, it is linear momentum multiplied by perpendicular distance from axis of rotation. So can you ask on just like, so linear momentum multiplied by whom? Perpendicular distance. Okay na? So what is angular momentum? Linear momentum multiplied by perpendicular distance. Then formula enti ante L bar is equal to R bar cross P bar. So this is the formula for angular momentum. Okay, angular momentum L bar is equal to P bar cross R bar cross P bar. Okay, now see, what is the linear momentum dimensional formula? M L T power minus 1. So angular momentum is equal to ML T power minus 1. multiplied by perpendicular distance. Are you clear? Perpendicular distance is nothing but distance. Distance unit is again what? Meter. Are you clear? Then its dimensional formula will be L. So therefore the total dimensional formula is ml square t power minus 1. So దీనికి మనం ఏమని చెప్పొచ్చు అంటే kg. Are you clear? Mass unit is kg, length unit is meter, so meter square by second. So kg meter square by second. T power minus 1 and a second. Okay, so just note down that, or else if you have in that study package, just underline that, because later I am going to explain one point. By that point we will use this. In that point we'll use this. Shall I move? Yeah, next I'll give you one more dimensional formula, that is torque. One more dimensional formula, that is torque. Are you clear? Now see, torque can be taken as force multiplied by perpendicular distance. Are you clear? What is torque? Force multiplied by perpendicular distance. Then the torque tau bar can be taken as r bar cross f bar. Now what is the dimensional formula? Means torque tau is equal to force ki dimensional formula anta cheppandi amma. What is the dimensional formula for force? What is the dimensional formula for force? Tell me, cheppandi amma. Dimensional formula for force ml t power minus 2 is there? Undamma chudandi. So dimensional formula for force is ml t power of minus 2, and distance, perpendicular distance dimensional formula L. Then the total dimensional formula will be how much? ml square t power of minus 2. Are you clear? What is the total dimensional formula for torque? ml square t power of minus 2. Then what is the unit? Means unit of force is what? Force unit ఏంటమ్మా? Newton. Perpendicular distance kada, distance unit ఏంటి? Meter. So therefore you can write unit as Newton meter. అర్థమైందమ్మా ఇక్కడ వరకు? ఓకేనా? Then one equation I'll explain one more thing. Pressure is there? చూడండి అమ్మా, pressure. Pressure formula is what? What is the formula for pressure? Means force per unit area. Now what is the dimensional formula for pressure? Force per unit area. ఇప్పుడు చెప్పండి, force కి dimensional formula ఏంటి? What is the dimensional formula for force? m l t power of minus 2 divided by area l square. Cancel 1l and 1l. ఇప్పుడు ఈ l డినామినేటర్లో ఉంది కదా, ఇది పైకి వెళ్తే ఏమవుతుందమ్మా? మైనస్ 1. ఒక l క్యాన్సిల్ అయిపోయింది ఆల్రెడీ. మా 1l got cancelled. One more l is left. Somebody came. Fine. But actually here two l's are there. In the two l's, one l got cancelled. Only one l is left. If this l goes to numerator, what is this value? ml power minus 1 t power minus 2. And unit for pressure is force unit ఏంటమ్మా? Force unit ఏంటి? Newton by area unit meter square, or this is also called as Pascal. Are you clear? This is the unit of whom? Pressure. Okay. Next one more thing is there, stress. ఉందమ్మా అది? చూడండి, స్ట్రెస్ ఉందా? ఆ స్ట్రెస్ కూడా సేమ్ ఫార్ములానే. We'll use this word frequently, right? So much of stress physics sir is given. I can't unable to bear this stress when this class will be completed like that, right? Yeah, stress. Stress is also force per unit area. Then what is the basic difference between stress and pressure? Means pressure is applicable to the fluids, whereas stress is applicable for the solids. Okay, na? Even we can use the pressure term also, it doesn't matter, like we have to use like that, but generally pressure word will be used for whom? Fluids. What are fluids? Liquids and gases. But stress is applicable for whom? Solids. Okay, so for this also then you will get same formula. What is that? ml power minus 1 t power minus 2. Okay, so and unit is what? Newton per meter square. Okay, even you can write Pascals also, no problem. Okay, so these are the some basic dimensional formulas. In that most importantly, you remember the dimensional formula for these quantities. If you by heart also, no problem, because these dimensional formulas will use repeatedly. Indulo first enti ante velocity. Velocity dimensional formula entama? Velocity dimensional formula LT power of -1. బ్లైండ్గా గుర్తుపెట్టేసుకోండి ఇది. ఓకే, నెక్స్ట్ యాక్సలరేషన్ డైమెన్షనల్ ఫార్ములా LT పవర్ ఆఫ్ -2. ఇది కూడా బ్లైండ్గా గుర్తుపెట్టేసుకోండి. నెక్స్ట్ ఎక్కువగా రిపీటెడ్గా వచ్చేది ఏంటి అంటే ఫోర్స్ ఫోర్స్ డైమెన్షనల్ ఫార్ములా MLT పవర్ ఆఫ్ -2. వన్ మోర్ థింగ్ రిపీటెడ్లీ వీఆర్ గెటింగ్ ఈస్ ఎనర్జీ ఆర్ వర్క్ ఆర్ ఎనర్జీ. వర్క్ ఆర్ ఎనర్జీ, ద వర్క్ ఆర్ ఎనర్జీ డైమెన్షనల్ ఫార్ములా ఇస్ వాట్? ML² T power of -2. Are you clear? Next, one more dimensional formula is there. One more dimensional formula, that is power. ఇవి కంపల్సరీగా గుర్తుపెట్టుకోండి, ఎప్పుడు రిపీటెడ్గా వచ్చేవి ఇవి. ఓకే, ML² T power of -3. ఈ 5 డైమెన్షనల్ ఫార్ములాస్ గుర్తుపెట్టుకోండి బాగా, ఎందుకంటే రిపీటెడ్గా వస్తాయి ఇవి. విల్ గెట్ రిపీటెడ్లీ. అండర్స్టూడ్? ఆర్ యూ క్లియర్ అప్ టు హియర్? నౌ షల్ ఐ మూవ్ టు నెక్స్ట్ పాయింట్. మా నెక్స్ట్ వన్, రైట్ డౌన్ dimensional or one important point. ఇది రాయండి, ఇది you write down one important point. Some 5 dimensional formulas compulsory you write up to power. Okay, write down one important point, like note point, whatever it may be. There is no dimensional formula for what? Strain. Strain rate. Fine, very good. I will give you the statement right on. There is no dimensional formula for strain. Obviously, don't have, but I will tell you the complete statement. Later, you can apply for anything. There is no dimensional formula for numbers. Angles, numbers, angles, trigonometric functions, so those are sine, cos, tan, cot, cosecant and secant, right? So for this there is no dimensional formulas, okay na? And angles, for angles also we don't have the dimensional formula. For angles also we don't have the dimensional formula. Okay, so write down. There is no dimensional formula for numbers, angles, trigonometric formulas, or equal trigonometric formulas, as well as logarithmic functions. Okay, logarithmic functions, దీనికి కూడా dimensional formulas ఉండవమ్మ. And also exponential functions. We cannot express the dimensional formula for these mathematical functions. For which mathematical functions we cannot apply the dimensional formula? Trigonometry, next angles, are you clear? Logarithms, as well as exponents, exponential functions, are you clear? In first year you studied the exponential functions topic, exponential types of equation, especially in the Newton's law of cooling concept. చదివారండి? గుర్తుందా న్యూటన్స్ లా ఆఫ్ కూలింగ్? ఏమన్నా గుర్తుందా? వేర్ యూ స్టడీడ్ దట్? thermal properties of matter. There we have the exponential functions based on that. Okay, and previously there is a concept of damped harmonic oscillations, but now it is deleted. There also we'll use the exponential, because exponential is the function where we can use to explain about the gradual growth or gradual decay. Are you clear? To explain about the gradual growth or gradual decay, we'll use which mathematical function? Exponential. Morning sir explained about the graphs in basic mathematics. గుర్తుందా? అది 3 లైన్స్ ఇలా డ్రా చేసి పైన ఈ పవర్ లాగ్ ఇది పెట్టారు కదా, గుర్తుందా? అది గుర్తుపెట్టేసుకున్నాం. ఎప్పుడైనా ఎక్స్పోనెన్షియల్ ఫంక్షన్ వచ్చిందంటే గ్రాఫ్ అదే నేచర్లో ఉంటుంది, లాగరిథంలో వచ్చిందంటే అదే నేచర్లో ఉంటుంది. సో దట్స్ ద రీజన్ వై వీ గివెన్ సమ్ బేసిక్ మ్యాథమెటిక్స్ క్లాస్ టు ద నీట్ స్టూడెంట్స్. ఎందుకంటే ఇవి బాగా వచ్చాయనుకోండి మనం అది చాలా ఈజీగా అర్థం చేసుకోవచ్చు. ఫిజిక్స్లో ప్రాబ్లమ్స్ ఈజీ అవుతాయి. రాస్తున్నారా బేసిక్ మ్యాథమెటిక్స్? ఫిజిక్స్లో రాస్తున్నారో సెపరేట్ నోట్సా? అసలు రాయడం లేదా? ఓకే, యూ జస్ట్ రైట్ డౌన్ బికాజ్ అది మీకు చాలా హెల్ప్ అవుతుంది. నేను సీరియస్గానే చెప్తున్నాను, చాలా సీరియస్గా చెప్తున్నాను. అంటే ముఖం స్మైలింగ్ ఉన్నా నేను సీరియస్గానే చెప్తున్నానమ్మా. ఓకే, నేను చాలా సీరియస్గా చెప్తున్నాను. ఎందుకంటే ఎంపీసీ స్టూడెంట్స్ దెర్ ఇస్ నో ప్రాబ్లమ్ ఎట్ ఆల్, బట్ బైపీసీ స్టూడెంట్స్ గుర్తుపెట్టుకోండి, మీరు మ్యాథ్స్ అంతగా టచ్ ఉండదు కాబట్టి మీరు అది కంపల్సరీగా చదవండి అమ్మ. అది చదివితే మీకు ఈజీ అవుతుంది. ఎందుకో చెప్పిన, మీరు రీసెంట్గా రీనీట్ కానీ అంతకుముందు జరిగిన నీట్ ఎగ్జామ్లో కానీ మీకు నేచర్ ఆఫ్ గ్రాఫ్స్ మీద క్వశ్చన్స్ వచ్చాయి కొన్ని. You have some questions on nature of graphs. First you have to understand the nature of graph, right? What is straight line, what is exponent, what is logarithm and all. Okay, actually morning I seen that live class. Actually when I am seeing that live class, sir explained about the graphs, right? So gudpetkondamma, adi chala important topic. Fine, now coming back to the concept. For these kind of trigonometric functions or else whatever these functions are there, we don't have the dimensional formula, remember. మా వీటిలో డైమెన్షనల్ ఫార్ములా ఉంటుందమ్మా? ఉండదు, గుర్తుపెట్టుకోండి ఇది. దీస్ డజంట్ హ్యావ్ ద డైమెన్షనల్ ఫార్ములా. నౌ షల్ ఐ మూవ్ టు ద నెక్స్ట్ పాయింట్. ఓకేనా? సో బేస్డ్ ఆన్ దిస్ ఐ విల్ గివ్ యూ ఫ్యూ పాయింట్స్, జస్ట్ ట్రై టు అండర్స్టాండ్. సో రైట్ డౌన్ ద ఫస్ట్ పాయింట్. కైనెటిక్ ఎనర్జీ. కైనెటిక్ ఎనర్జీ ఫార్ములా ఇస్ వాట్? హాఫ్ mv square. మా కైనెటిక్ ఎనర్జీ ఫార్ములా ఇస్ వాట్? హాఫ్ mv square. Do we have the dimensional formula for half? No, there is no dimensional formula for half. Are you clear? Then how to write dimensional formula for kinetic energy? Means mass dimensional formula m, velocity dimensional formula lt power of minus 1 whole square. Then you can write this as ml square t power of minus 2. Then we can write this as ml square t power of minus 2. Got it? This is the dimensional formula for whom? Kinetic energy. This is the dimensional formula for whom? Kinetic energy. అంటే పైన ఇచ్చే నోట్ పాయింట్స్లో మేబీ few things we will write the dimensional formulas. Okay, next one, angles. For suppose I will take angular velocity. Now look at the angular velocity. Okay, this you write, please. This you write. Okay, so for your practice, that angular velocity is taken as angular displacement by time. Are you clear? Angular velocity is taken as what? Angular displacement by time. So angular displacement means you can take it as theta by time is t. Do we have the dimensional formula for theta? No. Just now we told, right? For angles there is no dimensional formula. For time we have the dimensional formula. Then angular velocity omega is equal to 1 by time, that is equal to t power of minus 1. Is there? ఓకే, అక్కడ ఉంటే చూడండి, లేదా రాయండి అమ్మ, ఒకసారి రాసుకోండి ఇది. Now shall I give one more thing? Yeah, fine. For suppose in first year you see in this equation, displacement of a wave or displacement equation of oscillations. Okay, what is that equation? Means that equation is y is equal to a sin omega t. A sin omega t. Are you clear? Now see, do we have the dimensional formula for sine? No, because trigonometric formulas or functions doesn't have dimensional formula. Do we have the dimensional formula for trigonometric functions? No, that point, note point only given, right? There is no dimensional formula for trigonometric functions, logarithmic functions, exponents and numbers also, and angles also, even angles also. So దీని dimensional formula ఉంటుందమ్మా? No dimensional formula. But here A is called as amplitude. A is called as what? What we call A as amplitude. What do you mean by amplitude? Amplitude is nothing but maximum displacement. Maximum displacement. Displacement is measured in meters in SI system of unit. And meter ki dimensional formula enti L. So therefore the dimensional formula for y is equal to A, that is equal to how much? L. So ikkada y ki dimensional formula enta avutundi ante the dimensional formula for y is equal to A is equal to how much? L. Endukante sine ki there is no dimensional formula because it is a trigonometric function. Are you clear? Okay, na? Just write down this one. Write down even this example also to understand it better. Displacement equation of oscillation. Is it done? Then write down one more subheading, dimensional constants. Okay, dimensional constants. So some constants will have dimensional formula, whereas some constants doesn't have the dimensional formula. Ma pi value ento gurtunda? Pi value 3.14. It is a constant value actually. 3.14 is a constant value. Now what is pi value? 3.14. 3.14 is actually a constant value. For this numbers, there is no dimensional formula. Pi equal to 3.14 kada. Ante idu oka number kada. This number doesn't have dimensional formula. Ma that numbers doesn't have what ma? Dimensional formula. Just remember. So for numbers there is no dimensional formula. For pi there is no dimensional formula. Remember. Are you clear? But there are some constants which is having the dimensional formula. Ma there are some constants which is having what ma? Dimensional formula. In that, the first one is, I'll take Planck's constant. Clear? So write down Planck's constant. Are you clear? Planck's constant. Okay. We have the formula energy is equal to h nu, where E is nothing but what ma? Energy. And mu is nothing but what? Frequency. Okay, what is mu called as? Frequency. And what is this h called as? H is called as what? Planck's constant. Clear? What is h called as? Planck's constant. Now that Planck's constant h can be taken as E by mu. Are you clear? Planck's constant h can be taken as what? E by mu. Now what is E? E is nothing but energy, right? But that energy dimensional formula ml square t power of minus 2. And what is the dimensional formula for frequency? T power of minus 1. Frequency kuda calculate chesam kada. Ippudu 1 t power of minus 1, t power of minus 1 cancel అయిపోతుందమ్మ. So what is the left out terms? ml square t power of minus 1. Is the dimensional formula for Planck's constant. Are you clear? So note down this. Energy and work done will have same dimensional formula, remember. Okay, energy and work done will have same dimensional formula, remember that. Is it done? Okay na? ఇంకొకటి చదువుకుందామమ్మా. యూనివర్సల్ గ్రావిటేషనల్ కాన్స్టెంట్. యూనివర్సల్ గ్రావిటేషనల్ కాన్స్టెంట్ గుర్తుందా అది? Universal gravitational constant. Yeah. The next one is universal gravitational constant. Okay, the next one is universal gravitational constant. Okay na? Ma good petkondi. Just now I told you, just beginning of this topic if you remember. So what is that means? F is equal to g into m1 m2 by r square. మా ఇది గుర్తుపెట్టుకోండి, ఎస్పెషలీ ఇది ఎక్స్ప్లెయిన్ చేస్తున్నాను, ఇది గుర్తుపెట్టుకోండి. దీన్నే ఇంకొకసారి డ్రాబ్యాక్స్లో చెప్తా. మన లిమిటేషన్స్ మండే, ఎనీవే టుమారో హాలిడే రైట్. సో మండే ఐ విల్ ఎక్స్ప్లెయిన్ ద లిమిటేషన్స్ టాపిక్. వెన్ వీఆర్ గోయింగ్ టు స్టడీ అబౌట్ ద లిమిటేషన్స్ టాపిక్ ఐ విల్ ఎక్స్ప్లెయిన్ అబౌట్ దిస్ పాయింట్ పర్టికులర్లీ. గుర్తుపెట్టుకోండి. ఓకే, లిమిటేషన్లో ఇది ఒక లిమిటేషన్ అవుతుంది, గుర్తుపెట్టుకోండి. హియర్ జీ ఈస్ కాల్డ్ as what? Universal gravitational constant, that is represented with capital G. Now what is capital G called as? Universal gravitational constant. Then capital G can be taken as F into R square by M1 M2. ఈ ఫార్ములా మీకు గుర్తుంటే కనుక here F is what? Force. M1 and M2 are masses. R distance. Radius అనకూడదు, distance. Now tell me what is the dimensional formula for force? Tell me dimensional formula for force. ml t power of minus 2. Correct? My ml t power of minus 2. Distance dimensional formula L, right? Then L square, square undi kada. So what should be this value? L square divided by mass is what? m1 m2. So both are m and m only, right? So what is this value? M square. Cancel 1m 1m. This m will goes to numerator. Then m power of minus 1 L cube t power of minus 2. So this is a dimensional formula for యూనివర్సల్ గ్రావిటేషనల్ కాన్స్టెంట్. ఆర్ యూ క్లియర్? సో ఇది కూడా రాయండి అమ్మా. ఇఫ్ యూ డన్ విత్ దిస్ ఆల్రెడీ, వెరీ గుడ్. ఒక 2 చాలు. ఓకే, so these type of constant will have the dimensional formula. And one more thing, Stephen's constant, do you remember? చదువుకున్నావు ఎక్కడన్నా గుర్తుందా? స్టీఫెన్స్ కాన్స్టెంట్ అని బ్లాక్ బాడీ రేడియేషన్ దగ్గర వస్తుందమ్మా. the black body radiations will get Stephen's constant. So that Stephen's constant also, in Stephen's constant also we have the dimensional formula. అంటే అన్ని కాన్స్టెంట్స్కి డైమెన్షనల్ ఫార్ములా ఉండదని ఏం లేదమ్మా, కొన్ని కాన్స్టెంట్స్కి డైమెన్షన్స్ ఉంటాయి. లైక్ just now we discussed universal gravitational constant. Previously we discussed what is that? Planck's constant. Are you clear? Similarly some constants like ఏదైనా ఈక్వేషన్లో మనకు కాన్స్టెంట్ వచ్చింది అనుకో, ఓకేనా, ఆ కాన్స్టెంట్స్కి డైమెన్షనల్ ఫార్ములా ఉండొచ్చమ్మా. ఆర్ యూ క్లియర్? ఏదైనా ఈక్వేషన్ ప్రపోర్షనాలిటీలో ఒక కాన్స్టెంట్ ఉండిపోతే ఆ కాన్స్టెంట్కి మనకి డైమెన్షనల్ ఫార్ములా ఉండొచ్చు, గుర్తుపెట్టుకోండి. ఆర్ యూ క్లియర్ అప్ టు హియర్? ఓకేనా. మరి నెక్స్ట్ పాయింట్, డైమెన్షన్లెస్ క్వాంటిటీస్. Dimensionless quantities. Or even constants also you can write, no problem. Dimensionless quantities or dimensionless constants also you can write. నా దీనిలో గుర్తుపెట్టుకోండి, ఎప్పుడైనా సరే రిలేటివ్ అనే వర్డ్ కనబడితే for that there is no units actually. The best example, relative refractive index. Refractive index of the substance by refractive index of air. Relative density, density of the substance by density of water. Okay na? So when you compare the two different, same terms, okay, in the ratio, that ratio doesn't have the units. If it is not having the units, then there will be no dimensional formula. మా యూనిట్ లేకపోతే డైమెన్షనల్ ఫార్ములా ఉండదు, అంతే. ఆర్ యూ క్లియర్? మా వెన్ ఆర్ యూ టేకింగ్ ద రిలేటివ్, యూ హ్యావ్ టు టేక్ ద కంపారిజన్ బిట్వీన్ 2 సిమిలర్ క్వాంటిటీస్. ఆర్ యూ క్లియర్? రిలేటివ్ అంటే కంపారిజనే కదమ్మా, రిలేటివ్స్ అంటేనే కంపారిజన్ కదా, అంతే కదమ్మా. జనరల్గా అదే జరుగుతుంది కదా. ఎక్కడికన్నా వెళ్ళినప్పుడు ఏం చేస్తున్నారో బాబు, మా వాళ్ళు అమెరికాలో ఉన్నారు, నువ్వు ఎక్కడున్నావు, ఇదే కదా జరిగేది జనరల్గా, రైట్? సో ఇఫ్ ఐ గో ఎనీవేర్, లైక్ యు నో వాట్ యు ఆర్ డూయింగ్, ఐఎమ్ డూయింగ్ సంథింగ్, యు ఆర్ డూయింగ్ దిస్, మై కిడ్ ఈస్ డూయింగ్ సమ్వేర్ ఎల్స్, దిస్ కంపారిజన్ విల్ బి దేర్, రైట్? యువర్ కిడ్ ఈస్ డాక్టర్, ఓకే, మై కిడ్ ఈస్ ఇంజనీర్, లైక్ దట్ విల్ బి దేర్, రైట్? హీ స్టడింగ్ బీటెక్, ఐఎమ్ జస్ట్ స్టడింగ్ బీఎస్సీ ఓన్లీ, ఓ బీఎస్సీ ఓన్లీ, మై కిడ్ ఈస్ స్టడింగ్ బీటెక్, లైక్ దట్ దే విల్ కంపేర్, రైట్? ఫైన్, వాట్ ఎవర్ ఇట్ మే బి. సో జస్ట్ ఇట్స్ ఎ joke, okay? Jokes apart. Now relative means comparison between 2 similar quantities, right? So if I take relativeness, for suppose I'll take relative density, I'll take relative refractive index, I'll take relative permeability. Chadukunnara idi? Relative permeability, relative permittivity, that is also called as dielectric constant, if you remember. For these kind of things there is no dimensional formulas. Are you clear? My instead of writing everything, I'll write in a short point, you just write down, like, you know, relative density. Are you clear? What is relative density? Tell me what is relative density. So relative density is taken as density of substance by density of water. For this we don't have the dimensional formula and we don't have the dimensional, you know, unit also. Are you clear? Next, relative refractive index, or else one more thing, I'll take relative permittivity. Are you clear? Relative permittivity. Are you clear? Relative permittivity. So relative permittivity means K. Are you clear? Or you can write it as epsilon r. That can be taken as epsilon naught by epsilon naught. Clear? Epsilon by epsilon naught. Are you clear? Where epsilon is the permittivity of the medium, epsilon naught is the permittivity of free space. Gurtundamma idi? Yes. Then next one, relative permittivity. Clear? Relative permeability. Relative permeability. So which is taken as mu r, which is taken as mu by mu naught. So for these things we don't have the dimensional formula. Even if I take refractive index, if you remember refractive index, Refractive index. What is refractive index? Do you remember? Refractive index is nothing but velocity of light in air by, are you clear? Velocity of light in medium. It is a comparison between two things, velocity of light in air divided by velocity of light in medium. Velocity will have same units. Meter, that will be cancelled. So therefore here also there is no units and no dimensional formula. So for these kind of units, what we have, for these kind of physical quantities, there is no units and no dimensional formula, remember. There is no units and there is no dimensional formula, remember. Got it? Then keep the heading of the next topic, if you're done with this, that is principle of homogeneous. Yeah, keep the heading of next topic, principle of homogeneous. In principle of homogeneous, I'll explain 2 points. The first point is that, this is not the first point, before that I'll give you one more point. Must see, in addition or subtraction should be taken between the physical quantities having the same units or same dimensional formula. Are you clear? Which means that I'll take a physical quantity which is represented in kg. I will take one more physical quantity which also represented in kg. The addition or subtraction must be done with the physical quantities having the same unit or dimensional formula. Are you clear? Understood? Once again I will repeat, the addition or subtraction between physical quantities must be takes place between the quantities which are having the same unit or dimensional formula. సింపుల్గా మనం చెప్పుకోవాలనుకుంటే కేజీని కేజీస్తోనే యాడ్ చేయాలి, అలాంటి క్వాంటిటీస్ని మనం యాడ్ చేయాలి. ఆర్ యూ క్లియర్? ఫర్ సపోజ్ మీటర్ షుడ్ బి సబ్ట్రాక్టెడ్ ఫ్రమ్ మీటర్, దట్స్ ఇట్. ఆర్ యూ క్లియర్? మీటర్ షుడ్ బి సబ్ట్రాక్టెడ్ ఫ్రమ్ వేర్ మా మీటర్. ఆర్ యూ క్లియర్? ఫర్ సపోజ్ వన్ ఎగ్జాంపుల్ ఐ విల్ యూస్, యూ వెంట్ టు వన్ షాప్, యూ ఆస్క్డ్ లైక్ 1 kg of rice, then they put some kg, 1 kg of rice. For that you want to add 1 more kg. అప్పుడు ఏం చెప్తాం? ఇంకో కేజీ యాడ్ చేయండి అని చెప్తాం, అంతేనా? ఇంకో లీటర్ యాడ్ చేయండి అని చెప్పం కదమ్మా, అది ఇంకో లీటర్ రైస్ యాడ్ చేయండి అని చెప్పం కదమ్మా. ఇన్ కేస్ ఇఫ్ యూ టెల్ లైక్ దట్, హైదరాబాద్లో ఫేమస్ హాస్పిటల్ ఉంది, అక్కడికి వెళ్ళమంటారు, అంతేనా? తెలుసమ్మా, అది హాస్పిటల్ చాలా ఫేమస్ హాస్పిటల్ కదా, అది అక్కడికి వెళ్ళిపోమంటారు. ఎందుకంటే కేజీని కేజీస్తోటే యాడ్ చేయాలి. నువ్వు ఇలా చెప్పావు అనుకో, కేజీ రైస్ యాడ్ చేయండి, ఓకే బాగుంది, ఇంకొక లీటర్ రైస్ యాడ్ చేయండి అంటే ఇట్ డజంట్ మేక్ ఎ సెన్స్, యాక్చువల్లీ ఇట్ డజంట్ మేక్ ఎ సెన్స్. ఓకేనా? ఆ షాప్ కీపర్ నన్ను వేరేలా చూస్తాడమ్మా అప్పుడు. సో కేజీ షుడ్ బి యాడెడ్ టు హూమ్? కేజీ. మీటర్ షుడ్ బి యాడెడ్ టు హూమ్? మీటర్. ఆర్ సబ్ట్రాక్షన్ ఆల్సో మస్ట్ బి డన్ విత్ ద సేమ్ క్వాంటిటీస్, సేమ్ physical quantities. Are you clear? And one more thing, when kg is added to 1 more kg, the unit must be kg only. యూనిట్ కేజీ అవుతుందమ్మా. అంటే 1 kg + 1 kg 2 kg వస్తారంటే అవును 2 kg కరెక్టే, కానీ యూనిట్ మాత్రం కేజీ అవుతుంది కదా. ఇఫ్ యూ యాడ్ కేజీ టు కేజీ, యూనిట్ విల్ బి ద కేజీ ఓన్లీ. ఓకేనా? ఫర్ సపోజ్ ఇఫ్ ఐ యాడ్ 10 kg + 2 kg, వాట్ ఇస్ ద టోటల్ వాల్యూ? 12 kg. హియర్ 12 ఈస్ ద మ్యాగ్నిట్యూడ్ ఆర్ నంబర్. ఇది 12 అనేది నెంబర్, వదిలేసండి. బట్ కేజీ ఈజ్ నథింగ్ బట్ వాట్? యూనిట్. సో వెన్ కేజీ యూనిట్ ఈస్ యాడెడ్ టు కేజీ, వాట్ ఈస్ ద యూనిట్ అగైన్ యూ విల్ గెట్? kg only. Are you clear? Now for suppose I'll take 10 kg minus 8 kg. So what is the remaining value? 2 kg. Here 2 is a number, leave it. So kg, if it is subtracted from kg, again what is the unit you will get? Kg only. Are you clear? But this is the first point of the principle of homogeneous. Are you clear? Yeah, will you write that? Shall I explain in a short point? Write down. The addition or subtraction. The addition or subtraction must be done with the addition or subtraction must be done with the physical quantities having same unit or dimensional formula. Okay, na? So what I told, addition or subtraction must be done with the physical quantities having same unit or dimensional formula. Okay, the next point is that, now see, for suppose I'll take one equation like this. The equation is, let us take x equal to 80, something like that I taken. Are you clear? X equal to 80. A may be of any number, or else always A, Y. I'll take any other letter. Tell me one alphabet. 26 alphabets are there, right? ఏదో చెప్పండి, K anta. Okay, I'll use KT. So here K is a constant. Are you clear? Your name? No కదా, నీ పేరు నాకు తెలుసు కదా. So x equal to KT. Are you clear? X equal to how much? KT. Are you clear? K may be any constant. Remember, K may be any constant. Okay. For suppose left hand side, if they told this x as a displacement dimensional formula is what? L. Are you clear? Now please remember, if you made equal to symbol means, if you give equal to symbol means, left side and right side the quantities must have same dimensional formula. So therefore this entire term KT is there, right? KT dimensional formula also must be how much? L only. Are you clear? Now for suppose I'll take force F is equal to, I'll take some value. For suppose unko letter cheppandi me sir. V and okay na pere. So V into, for suppose I'll take one more number x. Are you clear? So here left hand side of the equation is force, right? Force dimensional formula entamma? ml t power of minus 2. Then Vx also must have the same dimensional formula, ml t power of minus 2. Please remember. Are you clear? This is the principle of homogeneous. What is the principle of homogeneous means? The left hand side of the equation and right hand side of the equation must have same dimensional formula. Are you clear? My left hand side of the equation and right hand side of the equation must have same dimensional formula. Remember this. Okay na? So write down the next point of principle of homogeneous. Both sides of mathematical equations must have same dimensional formula, or else you can simply write down LHS equal to RHS. Are you clear? Or left hand side of the equation must have same dimensional formula with the right hand side. Are you clear? Understood? So our left hand side and right hand side of the equation must have same dimensional formula. Okay, you can write like this also, left hand side and right hand side, LHS. Okay, left hand side and right hand side of an equation has same dimensional formula. Good petkonamma idi. Okay, based on this we have some problems. Today we'll do the problems on this principle of homogeneous. Monday we'll finish off this chapter. Okay, shall I move? Write down an example. One example problem. Okay, write down. X is equal to AT plus BT square. X equal to AT plus BT square. X equal to AT plus BT square, where X is displacement. Where X is displacement, T is time. Okay, A and B are constants, actually constants. Okay, what are the values of A and B? Now what are the values of A and B, or dimensions of A and B? ఇది ఇంకా బాగుంటుంది అలా వస్తే, dimensions of A and B. Okay, what is the dimensions of A and B? This is the question. Okay, I'll explain this question clearly, just go through it. So first you take the physical equation. What is the physical equation? AT plus BT square, right? Now what is the physical equation? X equal to AT plus BT square, right? Now what is the physical equation? X equal to AT plus BT square. But first left hand side chudandamma, LHS. In LHS side we have X, right? X and enti? Displacement. Displacement dimensional formula? L. So అయిపోయింది LHS. LHS done. Are you clear? Then take RHS. In RHS, how many terms are there? In RHS, how many terms are there? Two terms. Right? What are the two terms? AT is one term, BT square is another term. Each and every term of the right hand side and left hand side must have same dimensional formula. Plus or minus రాసారంటే ఇది separate terms అనే కదా. ఇదొక separate term, ఇదొక separate term, రెండు separate terms. Now first term is what? AT. That AT dimensional formula must be equal to how much? L. Are you clear? Then A is equal to L by time dimensional formula T అవుతుంది. ఎందుకంటే ఇక్కడ మల్టిప్లై అవుతుంది కదా, రైట్ సైడ్కి వెళ్తే ఏమవుతుందమ్మా? డివిజన్ అవుతుంది. సో దేర్ ఫోర్ వాట్ షుడ్ బి దిస్ వాల్యూ? LT పవర్ ఆఫ్ -1. ఇప్పుడు రైట్ హ్యాండ్ సైడ్ రెండో టర్మ్ ఉంది. వాట్ ఈస్ ద సెకండ్ టర్మ్ ఇన్ ద రైట్ హ్యాండ్ సైడ్? BT square. Now BT square dimensional formula is also what? L. Am I right? Then B dimensional formula is L by, here time is T. T square kada, so you can get it as T square. That can be taken as LT power of -2. This is the dimensional formula for B. Okay, na? So this is the answer. Just copy this solution. If you had already done this, I'll give you one more example. Is it done? Inko question ఏమన్నా? Shall I give another question? Just write down the equation NF, okay? The equation is F is equal to, or else, yeah, write down, no problem. AT plus, okay, BX by C plus T. Are you clear? Where F is force, X is displacement and T is time. Now I want dimensional formula for ABC. Okay, I want dimensional formula for ABC. What will be the dimensional formula for ABC? Yeah, try. A is very simple, right? A చాలా simple. Good. Is it done? See, F dimensional formula is what? What is the dimensional formula for F? రాసేవాళ్ళు MLT power -1. Write down LHS MLT power -1. That is equal to F, right? Then right hand side, how many terms are there? Two terms are there. AT is first term, BX by C plus T is the second term. Take first term first. AT should be how much then? RHS you take first. Take RHS. LHS is done. No, RHS you take. In RHS, what is the first term? AT. AT is the first term. Take AT. That AT should be balanced by, yeah, MLT power -2. Because each and every term of the left hand side should be balanced by right hand side. Left hand side, what is the dimensional formula? Tell me, what is the left hand side? This is left hand side. రైట్ హ్యాండ్ సైడ్ ఎంత ఏటీ, ఏటీ షుడ్ బి బ్యాలెన్స్డ్ బై ఎంఎల్టీ పవర్ ఆఫ్ -1. చేసామమ్మా, ఇక్కడ ఆగిపోయిందా సెకండ్ది. సి డైమెన్షనల్ ఫార్ములా ఎంత అవుతుంది, వాట్ విల్ బి ద డైమెన్షనల్ ఫార్ములా ఫర్ సి. ఒకసారి ప్రిన్సిపల్ ఆఫ్ హోమోజీనియస్ 2 ప్రిన్సిపల్స్ చదవండి. సి బోత్ ద ప్రిన్సిపల్ ఆఫ్ డైమెన్షనల్ ఫార్ములాస్, అదే ప్రిన్సిపల్ ఆఫ్ హోమోజీనియస్ చూడండి. అది ఇస్ ఇట్ డన్. స్కంద వాట్ షుడ్ బి, వెరీ గుడ్. చేశాను నేను. నువ్వమ్మా ఎల్హెచ్ఎస్ వచ్చిందా. ఎల్హెచ్ఎస్లో ఏటీ ఈక్వల్ టు ఎంఎల్టీ పవర్ -2 తీసుకున్నావు కదా. టీ అంటే ఎంత, టైమేనా. సో ఏ ఇంటూ టీ అని రైట్, లెఫ్ట్ హ్యాండ్ సైడ్ ఏ ఇంటూ టీ ఈజ్ ఈక్వల్ టు ఎంఎల్టీ పవర్ ఆఫ్ -2. ఇప్పుడు టీ నెట్ సైడ్ తీసుకెళ్ళి క్యాన్సిల్ చేయి, ఏమవుతుందో చూడు. క్యాన్సిల్ చేయడం ఏదో మల్టిప్లికేషన్ చేయి. మస్ట్ సీ హియర్ in this equation one parameter or one physical quantity we can find out very simple, in a very simple way. అదేంటి అంటే ఇది. Are you clear? Why? Because C plus T, the addition or subtraction must be taken between the same dimensional formula. Here T dimensional formula is what? T dimensional formula is T. Displacement dimensional formula L. Force dimensional formula MLT power of -2. Correct? So therefore, if I take C plus T will have the same dimensional formula. C and T must have what? Same dimensional formula. So the dimensional formula for C must be equal to how much? T. So first problem is done. C అయిపోయిందమ్మా. Are you clear? Then take LHS. What is LHS? LHS side we have force. Force dimensional formula MLT power of -2. Now you take RHS. RHS తీసుకోండి. ఇదేనా RHS? RHS లో 2 terms we have. This is the first term. What is the first term of RHS? AT. That is equal to MLT power of -2. Then A into time is what? T. That is equal to MLT power of -2. That implies A is equal to MLT power of -2 divided by T. The total dimensional formula is MLT power of -3. This is the dimensional formula for A. So A is also done, C is also done. అందరూ ఇది చేస్తారు మ్యాక్సిమం, అందరూ ఇది చేసేసారు. ఇక్కడ కొంచెం కన్ఫ్యూజ్ అయ్యారు, చూసుకోండి. C ఈక్వల్ టు హౌ మచ్ T, బికాస్ అడిషన్ ఆర్ సబ్ట్రాక్షన్ మస్ట్ బి డన్ విత్ సేమ్ డైమెన్షనల్ ఫార్ములా. ఇప్పుడు రైట్ హ్యాండ్ సైడ్లో మిగిలిపోయింది ఇంకోటి ఏంటమ్మా, వాట్ ఈస్ ద లెఫ్ట్ అవుట్ టర్మ్? BX by C plus T. That will also you can write MLT power of -2. Then B into X ఎంతమ్మా, X అంటే ఏంటి? డిస్ప్లేస్మెంట్ అయినా. డిస్ప్లేస్మెంట్ డైమెన్షనల్ ఫార్ములా L డివైడెడ్ బై C డైమెన్షనల్ ఫార్ములా T. Then T plus T, TA, not 2T. Why? Because it is a dimensional formula. Addition or subtraction must be takes place between same dimensional formula. ఒక డైమెన్షనల్ ఫార్ములాని ఇంకొక డైమెన్షనల్ ఫార్ములాకి యాడ్ చేస్తే we will get same dimensional formula. Are you clear? So therefore you can write C plus T, that is T plus T as T, that is equal to MLT power of -2. Cancel one L, then bring this T to the right side. Then B is equal to MT power of -2 into T power of +1. Then the total dimensional formula is MPT power of -1. Okay. ఓకే, మన ప్యాకేజ్లో ఎక్కడ ఒక ప్రాబ్లం ఉంది, అది చూడండి అమ్మ ఒకసారి. దే గివెన్ లైక్ దిస్, MLT పవర్ ఆఫ్ -2 ప్లస్ MLT పవర్ ఆఫ్ -2. ఆర్ యూ క్లియర్? దే గివెన్ 4 ఆప్షన్స్. దట్ ఈస్ ఫస్ట్ వన్ MLT పవర్ ఆఫ్ -2, సెకండ్ వన్ m² L² T పవర్ ఆఫ్ -4, థర్డ్ వన్ 2 MLT పవర్ ఆఫ్ -2, అండ్ ఫోర్త్ వన్ దే గివెన్ యాజ్ 0. ఓకే, ఏమవుతుందమ్మా ఆన్సర్? First option only, right? Because if you add the same formula, same dimensional formula with same dimensional formula, again you will get the same dimensional formula. You may think like 2 MLT power of -2, but 2 is constant. For constant there is no dimensional formula. Did you get it? Are you clear up to here? Yeah. So I'll stop today up to here. So tomorrow we'll discuss about the concept of, Monday we'll discuss the concept of properties, advantages as well as limitations of dimensional analysis. Go for break.